In this video tutorial, we shall see the logic and the program to convert a hexadecimal to decimal equivalent. Let us first look into the logic of the program. So this you have done in your basic electronics, right? Let's say I have a hexadecimal number. So I will consider this to be FDH, right? So what will be its decimal equivalent? Its decimal equivalent, if you use your calci, it will be 253 in decimal. Okay. So we shall store all these digits separately. Okay, 3 in one location, 2 in one location, 5 in one location, and 2 in one location. So maximum is FF. So maximum is FF. So its equivalent will be 255 in decimal. Right. Now, how do we do that? Right. So what the logic is as follows. I will take the number FD, and this will be divided by 10. That is 0A. So when I divide, so we know the division instruction, it is divide AB, right? So A will contain FD and B will contain A. So after this, the quotient, what we get is 19H, right? And the remainder we get is what we get is 03. Okay, so in the first division we get the lower digit. Okay, and we shall store this properly. Okay, so let's say this is 30H, this is 31H, 32H, and 33H. So we will have our hexadecimal number here. So this is hexadecimal number, right? Whatever the lower digit I get with the first division, so this I will store in 33H. Then this is the first step. In the second step, I will take the previous quotient, that is 19H. Then again I will divide by 0AH. So in that case, I will get the quotient as 02H and the remainder as 05H, right? So this 05 I will store in 32H and 02 I will store it in 31H. So if you see this, this will be 253H. That is the decimal equivalent of the hexadecimal number FD, right? So this is the logic of this program. Take the number, divide by 10, that is A, you will get the remainder. So the first remainder what you get is the least significant digit. So that I am storing here. So the next division you will get the next 2 digits. Okay, so let's write the program for the same. So let's begin the coding now. So where is our hexadecimal number? Our hexadecimal number is in memory location 30H, right? So we will take that number, move A, 30H, hex number, right? Now after this we have to divide by 0A. So for that I will take hash 0AH in B. This is the divisor, right? After this, divide AB. So once you divide, whatever the remainder you get, that is the least significant digit, and that we are planning to store at memory location 33H, right? So move 33H, B, right? And where is the quotient? The quotient is in accumulator. So in the next division, we have to take this quotient and divide by 10. Okay. So for that, already this quotient is in accumulator. Only thing is I have to move again 10 in B. Then I will say divide AB. So after this division, I get the entire result. In B, I will have this mid digit, which I have to copy to 32H, right? So I will say move 32H comma B and move 31H comma A, right? So this is the hundreds position. Yeah, that will be a good comment. Position. And this will be the tens position. And what we see here is the units position in decimal. Okay. So let's see the result. So let me initialize with FD. So I got the number, I'm dividing this. So I got 19 as quotient as expected. Remainder is 3. That I am moving to 33H. Next, I'm dividing 19 by A again. I got 2 and 5. So 5 I am moving here and 2 I am moving here. So 253 is the decimal equivalent of FD. Now the reason why we are not again packing these digits is because the default view of registers and memory is hexadecimal only, right? So it doesn't make any sense. Okay, we will try for one more number. Okay, let's say 9A. What is the decimal equivalent of 9A? Let's check in the calci. So 9A is 154. Okay, let's see that. So I got 4, I got 154. Okay, you can even check for FF the maximum. So it will be 255. Right? So it's absolutely fine.